Thank you.
So let me know if you see my slides.
Yeah, we can see your screen.
And you can, and it seems like you can hear me. Yeah, this sounds good. So
Yeah,
again, thank you. Thank you very much for this opportunity to present. And my topic today is going to be on the pore space and how it applies in lessons learned from already ongoing activities, not CCUS activities, but very similar and very much related to the projects moving forward, especially in the mid-continent, but anywhere else. And sort of it's going to be lessons learned from the current water and waste disposal projects from the Kansas, Oklahoma area, primarily Kansas, but Oklahoma is very similar in that regard. So we care about CCS in Kansas. Why should we care about CCS in Kansas is that we do have that history, of course, of there's a mature oil and gas industry, but there's also mature disposal industry. And as you will see, mature disposal industry is both good and bad. Good is because we do have experience in that. We do understand subsurface. We understand that we can actually store / dispose of a lot of fluid in the subsurface. But at the same time, that comes with some of the caveats that I will explain in a little bit. There's a rapid development of renewable energy. Kansas is currently #2 in the nation in terms of wind related wind generated electricity. So we have up to, sometimes the state consumes up to 50% of energy coming from wind. Depends on the season and when it is available. But kind of one of the, again, downsides of that is that we're sort of losing our backbone of our energy, the backload that comes from fossil generating facilities, similar to one that you can see on the picture below. It's Evergy's Lawrence Energy Center that will be discontinued in the next couple of years. This is a plant in the city where I'm currently speaking out of, and of course, if there's enough generating capacity from wind, it is great, but it's not always the case. And so I would hate to lose that kind of generating capacities around us. So we do have those large point sources of CO2, and it would be nice to keep them around, but maybe make them more sustainable and store that CO2 in the reservoirs, abandoned pore space that we have in Mid-Con. And also, it would be nice to bring in some of the CO2 into the CO2 EOR ready oil and gas fields in Kansas as well. So I'm going to talk about this Arbuckle and our Arbuckle reservoir. So Arbuckle Formation is it's a very thick group of formations that is extending from Kansas, from Nebraska, Kansas, and all the way into Oklahoma, in the Anadarko Basin, and in particular in Kansas, it is relatively both. It could be both shallow and deep, but basically it is very suitable for CO2 storage. But it is also suitable for storing other fluids as well, such as oil and gas waste, salt water, and also some of the hazardous waste, some of the waste from landfills, but also some of the municipal waste and some of the waste that is coming from various other sources. And so in terms of salinity, this is a mainly saline aquifer, but in some places in Kansas, it is actually can provide us with fresh water, but primarily it is saltwater aquifer. It is again deep enough, and the pressure regime is suitable for CO2 storage. In terms of, there was a question about well costs in Kansas. Well construction costs are lower than in a lot of other places, And for comparison, for example, in some of the deeper parts of the region, and this is coming from experience as a person who actually dealt with costs and procurement and operations for the wells. The cost for the well could be anywhere from about 500,000 to roughly 1.2 million, maybe 1.5 million tops for the well construction, for suitable for CO2 injection. So cost of operations are different depending on where you are in the nation. So what is kind of the timeline and why we are talking about this today? As you can see, yes, it is. Kansas is suitable for CO2. Suitable for CO2 sequestration project. Yes, it is possible to do in Kansas, and yes, there is a lot of knowledge about this, such as Wellington Field CO2 pilot, where we try to inject into via Class 6 for this sequestration project. But there is also a CO2 pilot that happened right above in the Mississippian Formation. And we do have class 2 wells that dispose of a lot of fluid due to Mississippian Lime and Woodford Shale development in conventional plays with very high water cuts, and those water cuts could be up to 95. Not actually, they're on average 95%, so they could be as high as 98%. And with that, a lot of water is being disposed, saltwater brine being disposed of in the formation below in the Arbuckle. And although it is a very thick and very pore space abundant sort of place, it is not unlimited, as you will see. And so that experience is what I'm going to be talking about is coming from me being an engineer on the Kansas Induced Seismicity Task Force, and where we talked about the induced seismicity caused by some of the waste disposal in the region. And how do we know about the seismicity? It's that there are KGS, USGS, and multiple seismic arrays that were installed in the area, so we know the location of the earthquakes and so on and so forth. So that is part, but the induced seismicity is only part of the discussion, as you will see. And of course, as a result of this injection, you will see the actions and from Kansas Corporate Commission, KCC, on that limited the injection volumes on some of those water disposing wells. And this will have an implication on the Class 6 wells going forward. And so even with the limited injection volumes, the Class 6, Class 2 well saga still continues. There's our Arbuckle working group out of the KGS, and not me, but some of my colleagues are leading that effort at the moment. And it is in some of the areas the CO2 injection would be problematic, specifically due to those issues related to Class 1 and Class 2 disposal wells. And so again, who is injecting into Arbuckle? There are two types of wells, and if this is, I'm not trying to be precise with the definitions, but basically, just for your understanding, kind of the background, the UIC Class I wells is generally Kansas Department of Health and Environment deals with those, and these wells are disposing of either hazardous wastes or industrial wastes. But these can also be some of the municipal water, and sometimes even fresh water can be disposed of in those wells. It depends on the situation. UIC Class 2 wells primarily deal with oil and gas waste, and these are the brine disposal waste that are coming from the oil and gas operations. And there are some differences in how they can be operated. One of those is that Class 1 wells cannot be operated under pressure. They have to be injected sort of on vacuum. So basically no wellhead pressure in there. And then Class 2 wells can be operated with some wellhead pressure. And so the Class 6 wells are also coming into picture. There's a number of projects that are either exploring to inject CO2 in subsurface. Some of them are as close as actually filing the UIC Class I permit. And so the various degrees of preparedness, but we'll see how they will move because they will have to navigate that kind of complex environment, and they will face the competition from those different other industries that already exist and compete for the pore space. So again, how do we know about those formations? There was we were lucky we had that Wellington project and the DOE support to explore the subsurface, and we tried and actually succeeded with the Class II injection and the pilot scale EOR. But the Class II 6 operation was a little bit different. But we have learned a lot in the progress in this process, and specifically for that Class 6 permit, we did have to install the seismic array to monitor for seismicity in the region, and we started seeing the seismicity as early as 2013 and before that, and so similar arrays were made for Patterson project, CarbonSAFE project, and for Wellington, and so we do know a lot about seismicity, but basically, again, in a nutshell, from 1981 through 2010, there was only about 30 recorded earthquakes, both felt and or recorded by the equipment. But then starting in about 2013, there was kind of uptick in recorded earthquakes, and from there it basically kind of blew up, and we do have some of the earthquakes recorded in the area as high as 4.9, 4.8, 4.9 magnitude in Kansas and 5.6 in Oklahoma. So pretty significant. These are already something that you can feel, and also people kind of get worried about what is going on, and there's a lot of attention to the people who inject in the subsurface. So here is again the progression. As you can see, there's just a specific region in Kansas that is kind of lighting up due to seismic activity. So you need to pay attention to the specific region, because that specific region is if you try to inject in that region, you will have to be prepared for a long debate if you go forward. And you can see also that this induced seismicity coincides with the kind of centered activity in the injected in where the fluids are being disposed of, both via Class 6 and Class 2 and Class 1. And so as you can see, the blue circles are the Class 2 water disposal, and orange circles are Class 1 disposal wells. And so seismicity generally coincides with where those focal points are, where a lot of sort of competition for the pore space is. Again, as you can see, there's uptake related to the development of the Mississippian Lime, uptick in the earthquakes associated with those Woodford and Lime development, and in 2012 and so on, where a lot more fluids started being injected in the subsurface, basically with the exponential kind of growth. But now it's subsiding because of prices of oil and other things, but people realize these plays are not as economical, and so as a result you see the decline. And here are some of the more precise volumes on the Harper and Sumner County, sort of focused area on the border of Oklahoma, where we see a lot of earthquake activity. We also see the fluid level and pressure rising in this area, and so you do see the impact of fluids being disposed in the subsurface, and primarily you see it in the fluid levels rising. And in some of the wells, unfortunately, especially those Class 1 wells where you don't have where you have a requirement of having not disposing of the fluids with the back pressure, they basically running out of space and will have to cease the operations and maybe go somewhere else, or they basically rethink about how they dispose of those fluids. And if this is the case, if you would plan any sort of other projects, including Class 6 project, you'll meet with a lot of resentment from both from the regulatory space, but also from your competing industries. And so as a result, for example, in the previous years where we saw a lot of seismicity as an answer to seismicity, we did see the actions from the KCC, and I encourage you, I will leave the presentation, of course, open, and you can see those KCC orders and what they mean in more details. But we did see the subsidence in the earthquake activity, probably both, due to limited injection volumes, and also probably due to decrease in oil and gas activity just in general due to prices and so on and so forth. And so, what helps in this situation? So there are two kind of lessons from here. Is that you will have the competition for the pore space in specific regions, and you have to be aware of this. But also you have to be aware of your surrounding and sort of do your due diligence. And DOE projects help with that. If not for DOE projects and CO2 related projects, we will not know about subsurface as much as we know about them about that right now. So thanks to those DOE projects, we know that the Arbuckle is a very complex reservoir. It's not very simple, and we know that it is actually in some areas it is baffled, and so there's no movement in between the zones. You can see it from the isotope data, from the pressure data, from various sources. You can see that there is no communication between lower Arbuckle and upper Arbuckle. There's extensive seismic surveys and geochemical surveys and so on and so forth. This is how we know now that the reservoir is much more complex than we previously thought about that. And so thanks to that, we could create complex geological models. And thanks to that, we can actually do very detailed simulations and engineer our resource better. And actually, if in the case of competition for the pore space, maybe we can manage the resource better. And so this is one of the solutions to manage the resource, and just to see, where your water is going, how it is going. Is it going closer? Is it the distribution is closer to the basement? Is it going into upper zones, and how do isolate the upper zones? All of those answers can be knowing this about the subsurface can actually help you to distribute fluids and actually do a safer type of injection. But this is in years to come, we'll have to manage the resource. Also, based on our simulations, we know that yes, there's a lot of space to hide a lot of different fluids in the subsurface to store them, dispose of them. But at the same time, it comes with a price, and so the space is not unlimited, and it's only can host only the limited number of projects in the area. And it comes from the simulations. It comes from those simulations that agree with what we see in the field, and we see the elevated pressures, we see the elevated fluid levels, and so on and so forth. And this is how we know it. You can explain this to general public via kind of approximations. Constructing complex models help in your scientific endeavors, in your engineering, but also you need to be able to explain it in a more simplified ways to the public, basically making approximations. That helps a lot. Also, there's you need to distinguish between different fluids that you inject, and we know that injecting CO2 is comparable to injecting other fluids, but at the same time there are some differences that we need to explore more, and we need to understand them more, and we will, as a result, we'll learn how to dispose of those fluids better. Also, there's a number of other resources that we can explore. For example, this Hugoton gas field is a huge reservoir on top of the many other reservoirs that exist in Kansas. Maybe we can use it as an alternative for saltwater disposal. There's also, Salina Basin that was underexplored. There's not too many wells that are drilled. We need to drill more wells in Salina Basin, and to characterize this project, this prospect as a pore space unit, not as a oil and gas unit. So there's prospecting for pore space is very real, not only for CO2 but for other industries as well. Also, there are basalts in Kansas, and we can explore that as a resource as well. And maybe in the future, if we drill a few exploratory wells and understand this resource better, we can dispose of fluids, different types of waste or CO2 or whatever in the basalts in Kansas and in general area as well, in the rift system sort of area. So I would encourage more drilling projects and exploration in that zone as well. So with that, thank you very much for hosting me. If you have any questions, please let me know.
Thank you so much, Mr. Eugene, for the great presentation. Actually, I have two questions in the chat. So Justy said, how many of the abundant oil and gas wells could be used for carbon storage? He also added, how can the big number of the caverns and the wells affect the current resident of Kansas?
So with the abandoned wells, it's a tricky question because some of those abandoned wells are they're either already abandoned, so it's difficult to re-enter. There are some of them that are not abandoned properly, or they have very old equipment. For example, in some of the areas that we looked at, some of the older wells, they will require a lot of workovers. Some of the wells don't have proper perforations. For example, from what we see, they're just kind of straw sitting on top of the reservoir, basically, collecting whatever is on the top of it without actually perforation. And so using abandoned wells is a tricky business proposition. Maybe could be done, but it's not easy or simple. So you need to have a kind of comprehensive look at this and actually do some sort of exploratory project on what are the costs and economic benefits in this.
Thank you.
And the second question was about
how can the big number of the caverns and the wells located affect the current residents of Kansas?
So the caverns question. There is karst. There is karst in Kansas, and so Arbuckle in some of the areas is very karsted. For example, in one of our CarbonSAFE wells that we drilled in the western part of Kansas, we had a drill bit falling a few feet. So it's not actually much in some other areas, but that kind of gives you a perspective that there is some permeability that is very fracture / karst type of related. At the same time, a lot of this karst is filled, and so it's especially in the deeper parts of Arbuckle, it shouldn't be an issue.
Okay, thank you so much. So that's all for the questions. If someone else have more questions, you can unmute yourself and ask it directly to the presenter. So I will stop sharing.